right, so you got a periodic table handy you can see. All right, so which element belongs to the alkali metal? Out of those four, which one belongs in the alkali metals? This would be a typical state test question. Okay? They expect you to know the name of that group. They expect you to look at
No.
what?
We're going to figure out the on the exam.
Yes. It's in your, you know, the green reference table I gave you or orange reference table I gave you? When you open it up, the front is the front cover, the back is the back cover, but when you open it, the whole inside is the periodic table. Okay? So, Janiyah says A. You can't talk. All right, Nathaniel says A. They're correct. All right, you have to know the alkali metals are group 1. You look in group 1 to find the element, and A is in group 1. Number 2. Now, for those of you who are not with them, the alkali metals are this group. Right there. K is right there. That's how you decide that. Everybody with us? Number 2. What's the name of group 16? The oxygen family is one name you can use. You could have called it the chalcogens, but most of you would call it the oxygen family. Remember what I told you? All of these groups are named by what? The first element. So group 13 is called the boron family. Group 14 is called the carbon family. 15 is the nitrogen family, and 16 is called the oxygen family. They're named by the elements at the top. Number 3, what property is special about group 18?
It's all gas.
It's not all gases. It's not all gases. Something we talked about yesterday.
It's all non.
I did it at the end of class yesterday. And what, Damien? It doesn't react. It has how many electrons? Has 8. Okay? It has 8 electrons, so it won't react. All right? This is what we're going to practice on that first worksheet. How many outer shell electrons does group 15 have? All right? Some of us still can't do this based on the quiz. 1, 2, 3, 4, 5, 6, 7, 8. Those are your outer shell electrons. They count 1 to 8. Now, you got your orange periodic table. The group numbers are at the top. If you have your orange one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many outer shell electrons in group 15? 5. But your orange periodic table has your group numbers at the top. You have to be able to count 1 to 8. All right. Will group 1 lose or gain electrons to achieve an octet?
It will lose.
It will lose 1 electron. We're going to review that in just a minute. That's why I needed the periodic. That's why I needed the smartboard back. Because we needed to draw it. Which element has 5 electrons in its outer shell? All right. Back to what I drew. 5 electrons in the outer shell is right here, right? Checking your elements right there. Which one has 5? Ca, Al, As, or Cl? Which one's in that group? All right, you're looking at group 15 right here. Which one's there? As is the right answer. All right, and then selenium-80. How do we find protons, neutrons, and electrons again? What do I need if I only have one number? What do I need to find? What is that number that they gave me? That's the mass. So I need to find the what? Where do I find the number if it's not given? Elizabeth, stop. Pay attention. All right. Where do I find the atomic number if it's not given to me? Periodic table. So I look up selenium. Selenium has a number of what right there in the box? Has what? 34. All right, so how many protons do we have? We have 34. How many electrons do we have? What do we know about protons and electrons? They have to be the same.
Unless it's
an ion. All right, how do I find neutrons?
that minus
80 minus 34.
equals 46.
Questions about how to do that? Yes or no? Questions on the opening? All right, now we've at least done the first thing we were supposed to do. Now let's review reactivity, and we'll come back to the property sheet, since some of us were struggling with those bullets. All right, you don't have to write this because we wrote it down yesterday. If you have your notes, feel free to pull it back out because I'm just talking about what's in your notes. All right, group 1 has how many outer shell electrons? Group 2 has how many? Group 13? Group 14? Group 15? 16? 17? And 18. Now, at this point, you should all be able to tell me that, okay? If you can't, you need to learn that. Now, this is the part we were working on yesterday. Every group up here wants how many electrons in their outer shell? That's their goal, is to get 8. Some of you have different goals. Atoms have a singular goal. They all want how many electrons? 8. Now, how they go about getting that is what we talked about yesterday. Group 1 can either lose 1 or gain 7. What's easier for group 1 to do? Lose. So it's going to lose 1 electron. Now, group 2 can either lose the 2 it has or gain 6. What's easier for it? So it's going to lose 2. Group 13 can either lose 3 or it can gain 5. What's easier? Lose. Essentially, everybody on the left side of the periodic table is going to do what with its electrons? It's going to lose. Okay? Now, when you get to the 4, it's the halfway point from 0 to 8. So it's going to do what? It can either, it can either lose or it can gain 4 electrons. Because we can't say what's easier, to either lose or to gain 4 electrons. It could do either one. Now, once we get past 4, though, what does it become easier to do? To gain. So now we're going to gain 3 electrons. When we get to 6, we're going to gain 2 electrons. Now, this information that I'm writing will be how we figure out oxidation numbers to write formulas, possibly late in class tomorrow. You thought we didn't what? We have class tomorrow.
In 8, no, that's a formulas.
Oh, we're going to learn how to, remember in middle school how you maybe did oxidation numbers and you did this crisscross and stuff to write formulas like that?
Oh.
That's the kind of formulas I'm talking about.
8 stays the same.
Yeah, you're not doing any kind of math formulas. Now, when you get to group 18, you already have 8. So what do we say was going to happen?
It's not technically happy.
Okay, they're happy. They're not going to lose any.
Did not react.
Okay, so they will not lose or gain. Now, so you guys have already told me what happens with the reactivity. So, now we filled in reactivity. Several of you have already said, because this group will not lose or gain, this one is stable. All right, it will not react. So, what does that mean about the reactivity for these other groups? So some of you, I asked, who is the most reactive? The ones that have the closest ability to get to 8 are the most reactive. So who's the closest to 8? The one that's only 1 away. So who is only 1 electron away from being at 8? That's right. So this one is the most reactive. Now, that means this one is the most reactive. The only difference is this one is a metal and this one is a non-metal. Okay? That's the only difference. Now, both of those are so reactive you can't be around them. These metals would explode in water, meaning if they were sitting on my desk, there's water in the air. It would explode. Okay? If you've been in Miss Rector's chorus room, she has a humidifier in there running all the time. In the warmer days when the heat's not on, they have to dump that sometimes multiple times a day. It pulls so much water out of the air. All right? There's water in the air all the time. It would explode sitting on my desk. In this group, chlorine and fluorine gas is so deadly, a little bit of it, if we were to breathe it, would kill us all. Okay? We cannot be around those things. They are not stable elements. They are that reactive. Now, what happens if we come in just slightly? Does it make them less reactive? Yes. Okay? They're still very reactive. Okay? But we call these moderately reactive. So, any of you ever played with like sparklers? Yeah. All right? Magnesium falls in this category. It burns really well. If you get it on your foot, what happens? It hurts really bad. You would not want to have a sparkler and try to grab a hold of it. Oxygen. We're able to be around oxygen, but any of you have any family members or grandparents who've ever been around oxygen? Can you smoke around it?
My grandma does.
Okay.
She's crazy.
Yep, she is. Not supposed to. Oxygen's just a little bit flammable. Okay? Now, is it as flammable as hydrogen, which is in group 1? No. Hydrogen in group 1 would explode. But in oxygen, it's a little more stable. It's a little further in on the periodic table. Not going to explode, but however, it could. It is a gas. It is under pressure. It's a little reactive there. It's not a good plan to smoke around it. Which is why it's not allowed in hospitals. Now, when you come in here, though, we call these fairly reactive.
Good job, William.
Meaning,
You shut up.
they will react, but they're pretty stable. So, nitrogen gas is in this crowd. If you know any people who smoke, 78% of the air that we're all exposed to is nitrogen gas. Do we have to worry about the people who smoke blowing up the air that we're around? No. The other night when I walked out of B Casa, there were 2 people standing there smoking. If the nitrogen air that they're around was explosive, I stepped out of the restaurant and kaboom! Would have been a bad place to be at that time. Okay? Now, we can get those elements to react. Like aluminum foil is there. We can get aluminum to react. I can add it to hydrochloric acid and get it to react. But unless I put it with certain things, will it react? No. Okay? But those group 1 and group 17 elements will react with almost everything. They have to be in mineral oil or they have to be in kerosene so they can't come into contact with almost everything. Okay? Does that make sense? Okay. So if we go back to the first worksheet we wrote, the one that had the properties. Now that I have my computer back. All right. All right. So, where are we putting 3 valence electrons real quick? Because some of y'all, I think, are still in the left field. Where are we putting 3 valence electrons? Group 13. Everybody there? Based on what we just reviewed, is everybody okay with 3 valence electrons in group 13? Yes or no? Okay. 1 valence electron goes where? Group 1. All right. 5 valence electrons goes where? Group 15. Aluminum is in this group, goes where? Jacob, hush.
13.
Group 13. Has 4 valence electrons, goes where? Group 14. We already did this one. They're non-metals, we said, could go in groups 15 to 18 because all of these things are non-metals. If I get a periodic table real fast. All right, we already said the non-metals were over here, right? The non-metals are here. So 15, see how they have group numbers right there? So 15 to 18 are our non-metals. Does that make sense? All right, so the next one. All the elements are gases. Who do we say were all gases? 18. All right, some of the elements are gases. This is why Bree was yelling at y'all not to put group 18 here, because group 18 doesn't have some that are gases because they're all gases. So you should have who for some? 17, 16, 15, and I said if you put it for 1, okay, because hydrogen is a gas. If you put it for 14, you need to erase it. 14 is not a gas. All right? Elements conduct electricity were what kind of elements? Metals. So where are the metals? The metals are where? 1, 2, 13, and if you put it for 14, 5. Okay? They are malleable. Same answer. 1, 2, 13, and 14. Who will gain 1 electron based on what we just talked about? 17. All right. Who's the most reactive non-metals now? 17. Okay. 17 were the most reactive non-metals. All right. Who will not react with anybody now? 18. I didn't. Oh. Who will not react with anybody? 18. 18 does not react with anybody. Who will now lose 2 electrons? All right, group 2. And who has 8 electrons in their outer shell?
18.
18. Everybody better on that now? Okay. Now, let's go to the other one that I handed you. All right, so if we look at this. All right, we have a periodic table, and it is, let me make it bigger here. And it's just sort of a fake. It's not real, and I've got fake elements there. Those don't represent any real elements, okay? So in question 1, it says, which pair of elements has the same number of valence electrons? What do they have to have in common to have the same valence electrons?
Same group.
Same group. So, which letters have elements in the same group? So you would write K and F for your answer. Okay? Does that make sense?
Yeah.
See how many of those you can answer before I stop you. Okay? I'm not giving you very long. Yes, some of them do have more than one answer. Like a number 2, there are actually, I think, 3 answers. All right? See how many you can answer.
That's supposed to be a D.
Yes.
Where at the bottom?
I'll show you.
Oh, I wrote an O there.
Yeah, this is actually, that's a D. That is R. All right, how are we doing?
I'm done.
All right, let's take some looks at what you got. All right, so we look at the first one. What do you look for to be in the same period? Who fits the same period? All right, I got Bree doing this number. Okay, so give me an answer for number 2 that you pick, charisma. Give me an answer that you pick for number 2, charisma. Who? D and R are correct. Okay, D and R are in the same period. That is correct. Can somebody give me a different answer? Huh? Oh, FOM. I was like, what? Okay. F, O, and M are correct. Yes. John. J and L are correct. Yes. Did anybody give me a different answer? Okay. I didn't know if somebody just said O and M or F and O or something like that, and that would also be correct.
Oh,
Foam. Okay. It's like, what? All right. Which pair of elements is in the same family? Any ideas?
Yes.
All right. Which one? K and F. I don't use the word family very often. You typically hear that word more at the middle school level than the high school level. But family is the same as a what? It's the same as a group. Okay? Carbon family, boron family, oxygen family, but family is the same as a group. So K and F. All right? Which element has the smallest atomic number? So who would have the smallest atomic number out of all of those? K. Okay? If you look at the placement of the elements on the periodic table, okay? Look at these. Don't tell me that thing just rebooted again. He says the hard drive's going.
It rebooted again.
Nope. It came back.
Oh.
And make it a little smaller. All right, so when you look at this and you look at the placement, the smallest atomic number is here, so it would be a 1. So who's in that same place here? Okay. All right. Which elements would be metals? Well, where are metals on here? Think about that. So which letters would be metals? Can you give me one that you picked, John? All right, I hear D and R. Those are good. Do I have any others besides D and R? All right, I hear K and F. I like all but one of those letters. Can anybody tell me which one?
It's a gas.
K is a what?
Yeah.
It's a gas. What's K's position up there? It's hydrogen. So K is the wrong answer. F, D, and R are correct. All right. Which elements then would be non-metals? J, M, and L. Why not O?
Because it's on the staircase.
It's on the staircase. All right. Several of you told me the non-metals were on the stairs, or the metalloids were to the right of the stairs. Where are the metalloids? Metalloids are where?
On the staircase.
On the staircase. The non-metals are where? To the right of the staircase.
Go right, bro. I messed up on my paper.
Some people told me the non-metals were where? They told me they were on the staircase, and some of y'all told me the non-metals were on the left. Who's on the left? The metals are on the left. Okay? Which one is a noble gas? L is a noble gas. All right. Who's the most reactive non-metal?
M.
All right. Why M?
17.
In group 17. Who has one electron in its outer shell? Is it only F?
It says a metal. Which metal?
Oh, sorry, metal. I skipped that word. Thank you very much. All I saw was the one electron in the outer shell. Yes, it has to be F because it said metal. Ms. Wall just saw one electron, so I'd have given you credit for K. But it can't be K because it said metal, and K is a what?
See, that's how it gets us on the exam.
It's a non-metal.
There we go.
All right. Number 10. Which element has 7 electrons in its outer shell?
M.
M. All right. If you have an atomic number of 20 for D, what is the atomic number for R?
23.
Yep. So 21, 22, and 23. And which element up here is a metalloid?
Oh.
O. Any questions?
Nope.
Feel okay about that? All right. We're going to do one more thing, and then we're going to switch up. All right, take it. Your hand. And they see our new last. You might be tired. Yeah, I'm still debating on the code. Because we could do bonding tomorrow. But today's our last day on the periodic table. And we're not going to do all of this. We're just going to do a part of it.
Comes to baseball after Christmas break.
You give me a ride.
We're But you have to please take all of that. Rate plus the
All right. Everybody have one? All right. What are these called again? What are these called again? These are called what? What do we build? Start with a B. Bohr models. Okay? So, this one is different than the one y'all built. In that, they don't have all of the dots drawn in. They only drew the outer shell electrons. Okay? So, when you take the state test, you may get one, if you get one at all, because again, there are only 45 questions, 5 of which are field test items. So you're not even going to be graded on 5 of the 45 you get. All right? Will you know which 5? No. They'll be intermingled in the 40. So, you may have topics that we've covered that won't even be on the test, and I have no idea what those topics are. So, you may not even see a Bohr model for all I know. So, if you get a Bohr model, and it has only one dot on it like this top one does, they're going to expect you to be able to figure out any of this information that I've asked for. So, how would you start? What things should you be able to find from that model to come up with the answer?
one balance list.
Okay. You should be able to look at this. Let me get a pen. And you should be able to say, oh, it only has one valence electron. Right? So, we know that there is one valence electron because there's only one on that outer ring. Okay? We are not answering anymore. So, if there's only one valence electron, you should now be able to figure out what other piece from that information. It's whatever. Group number 1. Okay? Because it has one valence electron, we know it's in group number 1. Now, something else we should be able to figure out. Not
It's a
quite.
metal.
Hold on.
No, it's
Hold on. It is going to be a metal, but let's go back to the period piece. It's not period 1. How do we figure out the period from that drawing? We already got group 1 because it's one outer shell electron. We're talking about the period.
The rings.
The rings tell the period. So, how many rings are there? So that means we're in what period? So now, using our trusty periodic table, and, okay, so we have period 1, 2, 3, group number 1, we are what element? Everybody okay with NA? All right, so, are we a metal, non-metal, metalloid, or a noble gas? We're a metal. All right, I want you to do the odd numbers. Okay? The odd numbers. There's a backside. All right, odds only.
remember this.
I'm ready to. Please tell me that thing didn't just cut off. I'm gonna be seriously annoyed. I think it just went to sleep. Okay.
You're on the edge with that computer right now, aren't you?
It just keeps rebooting in the middle of class for no apparent reason. And other than they think my hard drive is going, they don't have an explanation.
Get 'em.
Well, they could replace the hard drive, but all the ones they have are as old as the one I have. So they don't think it's really going to fix the problem.
I'm just getting a new hard drive.
Well, that would be the ideal fix, but we're $900,000 in debt. All right. Has everybody had a chance to try? Okay, I see a couple of people still on the backside. Well, I see a couple of people on the back. I mean, electronic ring shot. Periodic table. You do use it right there, right there. But you got your mind. That works.
Oh, damn.
1, 2, 3 electrons on this group. 1, 2, 3. Cross.
Oh, 'cause I was-
What are you looking at? Always look at this over here. I got it.
Aluminum is it's just instead of not another one. Okay, number 5. Yep. How many electrons you got? Yep. Right, 5. 3 electrons. All right. Everything ring you got? Okay. What's that? Now find your 5 electrons and your 3. Go across till you get 5 electrons. Could be what else? Is it a metal or non-metal or metal? Well, 15 is the group, 5 is the electron. All right. So if we look at number 3, how many electrons do we have? How many rings do we have? All right. So if we have 3 electrons, what group are we in? 13. What element are we? Aluminum. All right. Now, 1 electron, 2 electrons, 3, 4, 5, 6, 7, 8 electrons. Okay? Now, for the period.
Miss Ford. I said Miss Ford.
I know you did. I'm going to hold it against you.
Because we started from.
Miss Wall.
Okay. Now, I'm not writing you a note, so you better, if you run into an administrator, you tell them where you're going. All right?
I've been counting on me. On me, because I've been counting like 1, 2, 3, right?
You probably skipped.
Supposed to start from here.
Yeah.
Right, because I was just counting like 1, 2, 3.
Yeah.
So it started from
Yes. All right. So, is it a metal, non-metal, or metalloid? It's a metal. All right. This one has 5 electrons. It's group number 15. 3 rings. It will be phosphorus. It is a non-metal. All right. Number 7 has 7 electrons. Group 17, 3 rings. It's chlorine. It's a non-metal. Questions? Okay. Now, the last thing we're going to work on. Absolute last thing. Tomorrow we'll do bonding in the activity. We're going to look at the back side. Guys, we don't back up 10 minutes for the bell rings. I realize in some classes you do. We do not in here unless you want me to take my 10 minutes out of lunch. So you need a periodic table. For those of you who just packed up, you need to be able to see one. Unless you have it memorized. I've done this a long time. And even I still use a periodic table. Now, you need the back side. So turn to the back. That's what we're doing. Alright? So, if you look at the top clue. Oh, I didn't get you one tonight. I'm so sorry. Alright. So, if you look at the top clue, it says this element in this is in the same family as lead, but it has fewer protons than sodium. Okay, so we're going to use clues to answer the questions. All right, make it a little bigger this time. All right, so we have to be in the same family as lead. Okay, so family is lead. What does that mean? Same group. Okay, so find lead. I'll give you a hint. It's number 82. This is why I said you need a periodic table. You cannot do this without one. So find a periodic table. I don't care if it's colored or if it's got numbers on it. I will tell you sometimes it's easier with one with numbers. All right? So, lead is here, number 82. Same family as lead. All right? And it has to have fewer protons than sodium. Okay? So, sodium has how many protons? Protons than sodium. Sodium has how many? Has 11. Okay? So sodium has 11. But I have to be in the same family as lead.
Carbon.
So I'm going back over here to lead. Who in that family has less protons than sodium, which has 11?
Carbon.
So the answer is carbon. Okay? I want you to try to do 2 through 6. Here, come borrow this one. Mister, I lost my table.
I said pen. I don't
You lost your pen?
think
Try 2 through 6. Okay, read the clues and try to figure them out. The harder ones are at the bottom.
Why is it?
Hernandez, come on. Find me some answers. And Lucius, come on. I don't usually have to yell at you. You're going to have detention with me during lunch if you can't be quiet and do your work. Come on, find me some answers. Can we try at least a couple of them? Can we talk about their answers? See if you're on the right track? I'm only talking like 1 or 2.
Okay.
I wasn't going to do all 6. All right? Who's the element with an atomic number 1 greater than platinum? Okay. Platinum is here. Maybe. Come up, computer. Okay. Here we go. Get it up there. So platinum is here. So who's 1 greater than platinum? Atomic number 78. So who's 1 greater? 79. So gold. Are we okay with that one?
Yep.
Okay. So 3. The element has the most protons of any element in group 15.
Beyond.
All right. Bi, bismuth.
Yeah.
We're okay with that one? Can we do one more?
Yeah.
Okay. So number 4. This element has more than 50, but less than 75 protons, and it's in group 17.
Iodine.
Iodine? So we're okay on that one?
Yeah.
Did you do 5?
No.
Okay, so we didn't do, I hear Nathaniel telling me not to do 5 or 6 yet. Can you do 5 or 6 by tomorrow?
Yeah.
Just 5 and 6. Now, if you want to finish the sheet because you think it's cool, finish 1 through 10. I'd like you to do 5 and 6 by tomorrow. Tomorrow we're going to do bonding and we're going to do an activity that's cutting and pasting. Okay? But we're done with the periodic table.
We done with the periodic table?
What?
You said we done with the periodic table?
We're done with learning about it. We're going to use it to do bonding. You'll need it tomorrow to figure out who's metal, who's a non-metal to cut and glue, but we're not going to do any more learning parts of it. We got to move on because of the exam.
So stiff.
Have a good day. Stay dry. Might need an arc by the end of the day. You too, my dear. Bye, Damien. Bye, Nathaniel.
Photographer. Give my photo. Give my photo.